Okay, in OSI transport layer, OSI layer 4 transport layer, we have TCP, UDP. Now, which one will be selected? Who selects it? We need to understand this. Now, selecting TCP or UDP is not our choice. This is standard, predefined. Okay, who will select it? The operating system will select it. We don't have that job. Operating system, your Windows, your Linux, or whatever the operating system that you have, that is also designed using this OSI only. So with that operating system, when you try doing telnet, whether it is Juniper or Cisco or Windows or Linux or Mac, they are going to pick only TCP. TCP is the way of identifying a remote neighbor with whom you want to telnet. With UDP, you cannot discover neighbor. I want to repeat this. With TCP, you can identify the neighbor and form a relationship and then do the transfer of information. In UDP, you cannot find neighbor. See, I told you UDP is used in this voice and video traffic. Even I showed you by capturing packets. You saw everything was UDP. And you also saw RTCP, real-time transport control protocol. They all use UDP because I want fast communication. So between you and me, even though a session is maintained, but my laptop did not go to your computer and ask, can I form a neighbor with you? And your laptop did not come to my laptop and say, shall we form neighbor? Will you receive my packet? It didn't ask. That is UDP. It is best effort delivery. UDP is best effort delivery. Best effort delivery. Meaning, hoping that your computer is there to receive, I'll send. Just hoping. But not verifying. UDP cannot verify. So wherever I'm okay with hoping, wherever I'm okay with the best effort delivery, you will see UDP used. But Telnet is not like that. Telnet is I am seeing your computer in my computer. Seeing your computer in my computer. Have you seen Telnet? No, have you seen Telnet? You're not seen Telnet. Okay. Have you seen any remote login? It's same like that. Your computer in my computer. So I can do all configuration here for you, like remote desktop, Telnet. For this, I have to first of all establish a connection. And then only I can take your computer into my computer. We call it as remote login. If two computers, let me draw. This is AB. If you want to see this B, if you want to see this B here, if you want to see the B here, first thing need to be done is discover B. Go and find where B is. And then establish a connection between A and B. And then you bring B to A. Only then it will be possible. First need to be established. Connection need to be established. That's what TCP do. TCP is connection oriented. What does that mean? It establishes a connection before doing any conversation. See, whenever we speak in a phone, we do these things. What? First we listen for the ring. Is it ringing? Okay, it is ringing. Secondly, you listen for someone to pick it up and say hello. Yeah, he's saying hello. And then only you talk. Till the time you did not open your mouth. That is what connection establishment. In UDP, it is not like that. In UDP, as soon as you pick the receiver, you start talking. So phone cannot be an example for UDP. The phone example that I told you is to tell how the connection is established between A and B. A will wait for B to send some responsible hello or something. Someone should say hello. You see, I was waiting for your voice. I was saying good morning, I was saying hello, but your voice did not come. Why your voice did not come? Because you did not get that connection established. Meaning, you did not get that acknowledgement. I can speak only if voice come from the other side. So you are waiting. You are waiting, but you did not know that I am also waiting. I was saying hello, good morning, and I was waiting. You were waiting for me to say hello, but though I was saying, you didn't hear because there was a problem in your speaker, your headphone. If you did not hear hello from my side, definitely you would have not joined the class. So we fixed it through another medium, WhatsApp call, and we fixed it. Only then the class started. Otherwise, the class would have not been started if you still have that same headphone problem. That is what connection oriented. Best effort is not like that. There are 300 students online in the class. I cannot do connection check with everyone, isn't it? So what I'll do, I'll say 7:15 the class starts, and 7:15 I'll start, hoping that everyone can hear me. Maybe I'll check with one or two students, but what is the guarantee that all students are hearing me? Some may have mic problem, some may have speaker problem. But that is best effort delivery. That is called best effort. With 300 people, that is the best we can do. We cannot check with everyone. Do you hear me? Hello, good morning. How are you? Not possible, right? So both are needed, both TCP and UDP, both are needed, both are important, but not both used in same place. Some services will only use TCP. Some services will only use UDP. There are some services which will initially use UDP. After discovering neighbor, it will start using TCP. That's called multicast environment. In multicast environment, they'll use UDP until the neighbor is established, and then they'll switch to TCP. We are not going to get into those areas now, just too far topic. Now our focus is to understand the difference between these two protocol, TCP and UDP. As I said, TCP is connection oriented. Now, how we can explain better the connection oriented? Technically, I can say like this. Connection oriented is three-way handshake. Three-way handshake. It is what called as connection oriented. This is what called as connection oriented, three-way handshake. See, there's a computer here, and there's another computer here. Now they both want to communicate, but before they start their communication, they want to establish connection. How? Let's say A wants to talk to B, and B also want to talk to A. They want to do some important, they want to run between them some important service. So before they start that service, they want to make sure they both are connected. So what happens? A will send a SYN packet. You know what is synchronization? Synchronization? Yeah, syncing, correct. Synchronization. That's what called a SYN here. In short, they will say SYN packet. In order to synchronize each other, in order to establish this connection, it will send a SYN packet. A is sending, let's say A sends the first SYN packet. B will respond with acknowledgement, and B also want to talk, so B will also send its SYN packet. SYN also it sends, acknowledgement also it sends. Acknowledgement for what? B is sending acknowledgement for what it received, the SYN it received. And B is also sending its own SYN packet, for which now A will be sending acknowledgement. This is what we call it as three-way handshake. See, for the SYN A sent, acknowledgement is received. For the SYN that B has sent, acknowledgement is received by B. So now both knows that we both can talk each other. You understand what I'm saying? This is what called as three-way handshake. Actually, the SYN acknowledgement, these are all numbers. These are all numbers. You see, if this is, for example, I'm writing, usually SIN number will be very big number, like 7-digit number. I'm just making a small number here, 111. If A is sending 111, if B is capable of receiving it, then B will send acknowledgement 112. When A receives this 112, it understands that B has already received my 111. You understand now? See, it is not saying, B is not saying, I received your 111. B is saying indirectly, I received your 111. When B says acknowledgement 112, meaning what? Give me 112. That's what B is sending. B is saying, give me this next packet 112. It means to A that 111 has already reached B. That's why it is asking for 112. Likewise, along with this acknowledgement, B is sending its SYN packet. Let's say the SYN packet begins with 777. Now, A will send acknowledgement 778, isn't it? All right. This is how, in the real world, SYN and SYNAC is used. SYN and SYNAC. That's how we call it. SYN means synchronization. SYNAC means synchronization and acknowledgement. And then ACK. This is what called as three-way handshake. What is three-way handshake? SYN, SYNAC, ACK. If these three are successful, then they both are ready for the conversation. If this one of this is not successful, then three-way handshake will not be completed, then telnet cannot start. I repeat, whenever you do telnet or whenever you do some remote logging, very first thing will be this three-way handshake. See, three-way handshake is not carrying any data, but three-way handshake is needed for establishing the connection so that data can be sent. See, after this, if you send, you have some guarantee. But best effort delivery is not like that. It won't check like this. It will simply send hoping that the other guy is available. That is why TCP is considered as reliable communication. Reliable communication. Connection oriented, reliable. I just explained what is connection oriented. That is what we call as three-way handshake. All right, UDP is not reliable. Why? Because you don't know whether there is really someone receiving or not. You understand this UDP side? UDP is best effort delivery. But UDP is also important. TCP is important as equal as UDP is also important. See, if no UDP, then this online class cannot be conducted. Just imagine, after every 10 packet, after every 10 of my voice packet will be stopped and this three-way handshake will happen. And then again next 10 packet will be released. Again this three-way handshake will happen. Will that be nice? I'm asking you. இப்ப பேசிட்டே இருக்கிறோம். திடீர்னு என் குரலினுடைய பாக்கெட்டை நிறுத்திட்டு இருப்பா நான் கனெக்ஷன் செக் பண்ணிக்கிறேன் அப்படின்னு என் கம்ப்யூட்டர் வந்து கனெக்ஷன் செக் பண்ணிக்கிட்டு இருந்துச்சுன்னா அப்புறமா அதை திருப்பி ஒரு 10 பேக்கெட் அனுப்பிச்சிச்சுன்னா அப்புறமா திருப்பி கனெக்ஷன் செக் பண்ணிச்சுன்னா திருப்பி 10 பேக்கெட் அனுப்பிச்சதுன்னா நல்லாவா இருக்கும்? விட்டு 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 கேட்கும். So TCP is not good in that streaming traffic. UDP is the best. But when you're doing HTTP, what is HTTP? You're getting web page. You're typing google.com. See, getting Google page is not that fast as needed. Not now. To get Google page, you need only reliability, not that fast. See, we want our page to open fast, but compared to voice and video, getting a page is not that fast needed. Not needed. So it will use TCP only. Between your laptop and Google server, the three-way handshake will happen. I would like to show you that. So I have opened my Wireshark. Let's now go to the window and try to type some website, www.facebook.com, amazon.in. Now I got the page, but I'm sure the three-way handshake with Amazon might have carried out. I want to check that. Okay, I see one CCNA. I want to do a filter. Okay, this is SYN and ACK. I want to see first the SYN packets. Oh no, okay. Here we go. These are all SYN packets only. This will also contain SYN and ACK. So let us see the number here. The three-way handshake. SYN, SYNAC, ACK. To this may be the one. This may be the one. I hope so. No. First, second, I don't know where is the third one. Third one, no, not this one. I want to see all three complete. SYN, SYNAC, ACK. Oh, because I have put only SYN, it doesn't show. Okay, so that was the one. This number 15948 may be the one. So let me remove this. 15948. You see 15948. We have SYN, we have SYNAC, and the ACK, the last one, maybe. Let me see the packet number. ACK is in 1594 eta. Right. Okay, that's the beginning. Sin ACK, and okay, if you trace this line in the left, you will know where it ends. So it took some time for getting the last acknowledgement. Oh, it has gone up somewhere. Here it is. Yes, this is ACK. Three-way handshake got completed. So if you notice, the IP address is 13. 13. This must be the Google. I'm going to say IP address equal to. What really happened? I want source or destination. This is source. Long time I did not use this tool, so I'm forgetting. Okay, or like this. So I'm going to put this 13.249.217.35. Okay, so I see a lot of things. Okay, here only this first three packets. You see, it is SYNAC, and ACK. And who is sending the SYN? If you see 192.168, it's me. My laptop is sending SYN first to the Google 443 Google, and Google is sending SYN plus ACK to me. You see here, SYN ACK, and then followed by me sending acknowledgement. Now let's go to the top again, and you can see the SYN here. Mhm. You see, I told you the SYN packet, the SYN will be a big number. The sequence number, you see this one. You see 53 here. In the next one, if you see acknowledgement in this place, you'll see 54 in the next packet. You see 54. Do you see that? And that's what called as forward acknowledgement. Now, three-way handshake after three-way handshake gets over, the other things will come, like it will go and fetch the page for you. So before starting the main conversation, you say hello in the phone. Do you really want to tell hello to me this morning? No. No one wants to simply say hello. There is no meaning in that. we want to talk something important, but every time when we call someone, we say hello only. That is how you establish the connection first. Hello is not the main matter that we want to talk, but still we say the hello to establish connection. Same like that. TCP conversations will do this three-way handshake first, and then only the main conversation will start. That is why we call TCP as connection oriented. Okay, now we are going to next topic. In OSI layer, what is the name of layer for? So you should remember this in order. What is the top layer, seventh layer? Exactly. What is the next layer, sixth layer? Presentation layer. And then, exactly. Next. Yeah, see? 7, 6, 5. This is 4. Always fourth layer is, yeah. Always the fourth layer is transport. And then the third layer is always network layer. Second layer is always a data link layer. First layer is always physical layer. Always. It should not be changed. This is not just a sequence number. Now, why do I insist on this number? Because sometimes people will not say transport layer. They will say layer 4. It means what? Exactly. So we should know this. In transport layer, we have seen now two main jobs carried out. Number one, according to the capacity of your device and the network capacity, the segmentation is done. You remember? The packet, the big data is chopped into small pieces according to the capacity. And then sequence number is assigned. Next is TCP or UDP will be selected. Now, based on the application layer, based on the application that you start, transport layer will decide this. If your application is telnet, transport layer will give TCP. If your application is some online webinar tools like this, Google Teams, Microsoft Teams, or whatever, WebEx, like Zoom. If that is your application, then again, transport layer is going to be UDP. So depending on what is selected in the application layer, the transport layer is going to decide here whether to use TCP or UDP. Now, the third job this fourth layer will do is picking up the port number. Port number. Port number. You see, you will see a port number in all TCP packets. And if you see here, the destination port number is 443. What does this 443 means? You see the TCP, right? Transmission Control Protocol. It's layer 4. You see here. I would like to show you very clearly. This OSI layer you can see here. This is layer 1, layer 2, layer 3, layer 4. You see? Layer 4, actually, for your understanding, I said this is layer 1. It's not truly layer 1. These two, no, these two called as layer 2. Frame and Ethernet, this is layer 2 only. Both are layer 2 only. Layer 1 is a physical layer. You cannot see it here. It is the way that which the connection is made, maybe through wireless or through wire. You're connecting your laptop, right? That is layer 1. So this Ethernet and this one, these two both together is layer 2. This is layer 3 where IP addresses, you see here, the source, IP address, my computer IP address, the destination IP address, this is Yahoo. Sorry, this is in Google's. Did I say Google in the web page? I think I was opening Amazon.com, right? This 13 is Amazon. Let us try. Let us try. Let us check it. Is it Amazon? CMD, go to command prompt and try pinging www.amazon.in. Look at this. You see that? 13249. Huh? It's same number. So the Amazon that I requested. So who gave this IP address to the packet? It is this layer 3. Internet protocol network layer. Okay. Layer 3. And then this is layer 4. TCP is used in layer 4. And layer 4, it has not only given, it is not only doing SYNAC, all the stuff, it is also not only giving sequence number, it is also providing port number. Is it so important? Yes, it is very important. Port number is very important. You see, you are going to 13.249.217.35, which is amazon.in. But what is that? 13.249. It is an IP address of the computer, Amazon's computer. Correct. See, that computer can do 10 different jobs. What do you exactly expect from that computer to give? Amazon's web page, isn't it? See, that computer also can ping. Are you willing to ping with them? No. Are you trying to do some Zoom chat with them? No. What exactly you are trying to do? You are trying to get their web page. Getting web page is what this 443 means. 443 means HTTPS. That's the protocol that will get the web page from there. See, with the help of port number, we are telling what we are expecting from that 13.249.217.35. You know, so if I'm sending you to somewhere to meet someone, let's say I'm sending you to Netherlands, Vodafone office. Fine. You took the Google map. You saw Netherlands. Where is Vodafone office? There is one in a place called Haarlem. That's very deep inside of Netherlands, where no Indians are. And you go there. You took the taxi. You took train. You took tram. You even took some boat. And you reached Haarlem. And then you reached Vodafone office. Fine. Is there anything useful there? No. If I say go to Vodafone Haarlem office, that's not a complete job. What you need to do after reaching there, that's important. That is what this port number will do. This port number will tell you what to do after reaching that IP address, after reaching that after reaching Amazon server. After reaching Amazon.in server, what are you looking for? If you are looking for their web page, then port number should be 443. If you are looking for telnet, the port number will be 23. I repeat, if I am telnetting to 13 dot this address, amazon.in address, if I'm telnetting, the port number is 23. Telnetting means like remote login, I told you. If I want to see their computer in my computer, then it is 23 port number. But when I open the browser, can I do telnet? No. Browser is an application layer. It is meant to get the web page only. That is why 443. Did I say 443? No. I I opened the browser and I typed amazon.com. Automatically the operating system has put port number 443. My computer operating system is saying that I'm looking for their web page. To say that I'm looking for their web page, it says 443. You understand now what is this port number? Port number is to identify services. Got it? Services. What service? HTTPS service, web page service. If it is 23, what service? Telnet service. Okay, now only 2 port numbers I have taught you. Remember, port numbers are important. Not all port numbers, few port numbers are important. I'll be telling you once in a while. To get the web page in a safe mode, port number is 443. And the protocol name is HTTPS. HTTPS is 443. For telnet, port number is what is the port number for telnet? 23. Okay, so this uses HTTP or UDP? Sorry, this uses TCP or UDP? TCP. You see here, TCP, Transmission Control Protocol. TCP 443 is HTTPS. TCP 23 is Prime. TCP 23 is TCP 23 is Telnet. TCP 443 is exactly. Now, what is the port number for HTTP? For HTTP, the port number will be 80. 80. TCP 80. For simply HTTP, HTTP is not safe. HTTPS is safe. Simply HTTP means it is 80. HTTPS means 443. TCP 443, TCP 80, TCP 23. 3 port numbers I have taught you today. You see that the layer 4 is giving source port number and destination port number. Yeah, it provides port number, TCP or UDP. Even UDP has got port number. Let me show you the voice traffics. You see this UDP packet. This also got port number. You see source port number, destination port number. Yeah, but you cannot remember all those thousands of port numbers, but whatever we frequently use, those port numbers we should remember. For example, Telnet is 23, HTTPS is 443, HTTP is 80. All right. So we have finished this layer 4. We'll get into layer 3 and layer 2 in our next class. Right. We'll start